Hello everyone, welcome to the PRP lecture videos. I am Dr. Chaudhary, Associate Professor, Department of Mathematics working in RMD Engineering College. In this video, we are going to see the two-dimensional random variables. Okay, two-dimensional random variables, there are two parts. One is discrete, another one is continuous. In this video lecture, we have seen only discrete random variables. What is the definition? If the set of all values of x, y is finite or countably infinite, then the pair of x, y is called a two-dimensional discrete random variable. The values of a two-dimensional discrete random variable may be represented as xi, yj, I equal to 1, 2, 3, up to infinity or some finite value, j equal to 1, 2, 3 up to infinity or some finite value. Okay, now what is finite and countably infinite? Let us see some examples, we can understand the concept. What is finite set? A set is finite, it has a limited number of distinct outcomes. For example, if we toss two coins once, we may denote x equal to number of heads obtained. We denote y equal to number of tails obtained. Okay, what are the possible outcomes? Head, tail, head and tail. So what is observation? 2 heads, 0 tail. 1 head, 1 tail. 1 head, 1 tail. 0 heads, 2 tails. Okay, here all x represent head, y represent tail. So 2, 0, 1, 1, 1, 1, 0, 2. Okay, well, define as I said, the repeated value is not possible. So we take only once. So what is the set? 0, 2, 2, 0, 1, 1. So the possible outcomes are only 3, that is finite, 0, 2, 1, 1, 2, 0. Next, the countably infinite set. A set is countably infinite if its elements can be listed in the sequence like 1, 2, 3, up to etc. But the list never ends. But we can guess. How you know? See, we define x equal to number of customers arriving in 1 hour. Number of customers arriving in an hour. For example, within 1 hour, no customers arrived. 1 customer arrived. 2 customers arrived. 3 customers arrived. Up to several customers are arrived. But within 1 hour, we can easily count, but we couldn't predict how many customers are arrived. Like that, y. Number of defective items sold that day. Suppose the manufacturer, retailer sold some items. We count the number of defective items per day. Sometimes 0 defective items, sometimes 1, 2, 3 up to etc. See the possible pairs of x, y. 0, 0, 0, 1, 0, 2, like this 1, 0, 1, 1 up to etc. Both x and y can take infinitely many integer values, but still is countable. Okay. Okay, now let us come to the important topic, the joint probability mass function of discrete random variable. So already we have seen probability mass function of discrete random variable x. That is what P of x. Here there are two variables only now, x and y. So let x, y be a two-dimensional discrete random variable with values xi, yj. Here capital Xy stands for random variable, small xa and yj values. I equal to 1, 2, 3 up to etc. J equal to 1, 2, 3 up to etc. So the function assigns each real number xi, yj a real number. What is the probability value? P of xi, yj equal to, that is probability of random variable at xi, probability of random variable y at yj. Is called the probability mass function of x, y, or joint probability mass function of the random variables x and y. See, what is the condition? Non-negativity. Each and every probability values are greater than or equal to 0. P of xi, yj greater than or equal to 0 for all I, j. Also, total probability is 1. There we have only one row. For example, for single random variable x, some values are and corresponding P of x. Adding all the probability values is come 1. Here x and y. X values are there, y values are there. Inside the pair of elements values are there. However, it is all the values when we add, answer equal to 1. That is what? Total probability value equal to 1. Okay. Example. We will take the same previous example, tossing two coins. Let x equal to number of heads, y equal to number of tails. So what are the possible values? Two heads, two tails, and one head, one tail. Except the three elements, other elements are 0. That is not possible. See the total probability: 1 by 4, 2 by 4, 1 by 4. See, 1 by 4 plus 2 by 4 plus 1 by 4. LCM is 4. Numerator 1 plus 2 plus 1 equal to 4 by 4 value equal to 1. So second probability value, second condition is over, and each and every probability values are greater than or equal to 0. Why 0, 0 is not available? 0 head, 0 tail. At least one tail may be there. At least one head. So the event no heads, no tails are not available. Like this here and here, here, here. Okay. Next, the marginal probability mass function. Here we are taking x comma y pair. Out of two pair, will we concentrate only x alone and y alone. That is marginal probability mass function of x and y. Okay, that means marginal probability mass function of x and y are obtained by summing over the other variables. While look at x, probability mass function of x summing over y. The probability mass function of y summing over the j. Sorry, summing over the x. Have you understood? Let us see one example. Example. Look at this for y values and x values. These are the probability values. Okay. Now, see probability function of probability marginal function of x, 3 by 10. How you know? While we look at x equal to 1 for the probability function p of x equal to 1, summing over the y values, y equal to 1, y equal to 2, y equal to 3. See this, add these rows. See what happened? 1 by 10, 3 by 10, 1 by 10. See, 1 by 10, 3 by 10, 1 by 10. Take the LCM 20. So 1 into 2, 2. 2 plus 3 plus 5, 5 plus 1, 6. 6 by 20 equal to 3 by 10. Next, for x equal to 2, 1 by 20, 1 by 5, 1 by 10. This is what? Probability of x equal to 2. When we find the probability marginal function of x equal to 2, we add summing over the y. Y equal to 1, y equal to 2, y equal to 3. So we can get 7 by 20. Like that for x equal to 3, we add 1 by 20, 1 by 10, 1 by 5, we can get 7 by 20. This is for what? P of x equal to 3. Okay. Now probability marginal function of y. P of y equal to 1. Summing over the x. X equal to 1, x equal to 2, x equal to 3. 1 by 10, 1 by 20, 1 by 20. What is the answer? 1 by 5. Let us see. LCM is 20. Here 10 only know. To make LCM 20, 2 plus 1 plus 1. So 4 by 20 equal to 1 by 5. Like that for this is what y equal p of y equal to 2 and p of y equal to 3. Okay. So however it is, when we add this probability mass function of x values, probability mass function of y values, answer comes 1. Answer comes 1. See the verification for marginal probability function of x, p of x equal to 2, p of x equal to 3, 3 by 10, 7 by 20, 7 by 20. For marginal probability mass function of y, 1 by 10, summing over this one, 1 by 5, 9 by 20, 7 by 20. Okay. Next, conditional probability. For two discrete random variables x and y with the joint probability mass function p of x comma y I. Suppose probability of x when y is given, probability of y when x is given. What is the condition? P of a by b formula, p of a intersection b divided by p of b. Like this, p of x comma xi comma yj divided by probability mass function values y. Like that for x. Okay, here note this condition. The denominator value should be greater than 0, not equal to 0. Okay, let us see the previous example. 1 by 10, 3 by 20, 1 by 20, take these values. Now I want to find conditional probability x equal to 1 when y equal to 2. When y equal to 2, now this is 1, y equal to 2. What is x equal to 1? 3 by 20. Okay, what is the condition? X comma 1 comma 2 value equal to 3 by 20. Corresponding probability marginal function value 9 by 20. So 20 will be cancelled. 3 by 9 value equal to 1 by 3. Okay, for the same row, x equal to 2, what is y equal to 2? 1 by 5. 1 by 5. So P of x equal to 2 comma 2 divided by P of y of 2. What is the answer? 1 by 5 divided by 9 by 20. So 5 and 20 will be cancelled by, this is what, make it 4 and this is what, 20. Okay, 20 will cancel, answer 4 by 9. Answer 4 by 9. Okay, like that. Probability of y equal to 3 when x equal to 2. So denominator probability marginal function of x at 2. So what is probability marginal function of x equal to 2? 7 by 20. 7 by 20. So, okay, so here 3, 2, x value equal to 2, y value equal to 3. So 2 comma 3 value equal to 1 by 10. So 1 by 10 divided by 7 by 20 value equal to, take LCM here, 2 to 20. So 2 by 7. 2 by 7. Okay. Next, independent random variables. Two discrete random variables x and y are independent if and only if each and every probability values p of xi comma yj equal to product of corresponding marginal probability mass function. So px of xi, py of yj. That is, the joint probability mass function equal to product of the marginal probability mass functions for every pair of xi comma yj. Let us see one example to understand the concept. Roll a Faraday once. Let us define x equal to 1 and 0. When 1, if the dice shows an even number, that is 2, 4, 6. Whenever dice shows 2, 4, 6, answer comes 1. If for all numbers 1, 3, 5, answer comes 0. Let us define same way y equal to 1 and 0. If the dice shows greater than 3. So what are the greater than 3? 4, 5, 6, 1. What is the less than 3? 1, 2, 3. If it is 0. See, once again repeat, when x equal to 1 for even number 2, 4, 6, when x equal to 0, odd number 1, 3, 5, when y equal to 1 for the 4, 5, 6, when y equal to 0 for the number 1, 2, 3. Okay, now joint probability mass function. Outcomes of dice 1, 2, 3, 4, 5, 6. Now x has some condition. For 2, 4, 6, 1, 1, 1. For all number 0, 0, 0. For y greater than 3, 4, 5, 6, 1, remaining 0, 0, 0. So what is a pair? 0, 0 comes 2 times. So 2 by 6 equal to 1 by 3. 0, 1, only once, 1 by 6. 1, 0, out of 6 outcomes, only once, 1 by 6. 1, 1, here and here. There are 2 possible. So 2 by 6 equal to 1 by 3. Okay. Now I am going to take P of 1, 1, 2 by 6. See, P of 1, 1 equal to 1 by 3. Answer, we know that P of 1, 1 equal to 1 by 3. Okay, so how we can write product of probability mass function? Px of x value equal to 1, Px of x value equal to 1, Py of y value equal to 1. Okay, so Px of 1 value equal to 1 by 2, Py of 1 value equal to 1 by 2. Product of these two equal to 1 by 4. Now here 1 by 3 not equal to 1 by 4. So x and y are not independent. If both values are equal, x and y are dependent. Why it is independent, you know? Because tossing coins, tail and head, both are dependent. That's why answer comes not independent. Previously, we have seen an example, you know. For this example, both are what different. If you are selecting the probability value from and apply the concept, we can get independent. Okay. Okay. Now let us see one example. See this example. 3 balls are drawn at random without replacement from a box containing 2 white balls, 3 red balls, 4 black balls. Let X denote the number of white balls drawn and Y denote the number of red balls drawn. Find the joint probability distribution of X, Y. So question is only we are going to form the joint probability distribution of X and Y. See, total balls are what? 2 white, 3 red, 4 black. So totally 9 balls. So draw 3 balls without replacement. So we denote X number of white balls, we denote Y number of red balls. So what about black balls? After that subtraction of white and red only, we can take the count black balls. Okay. So possible of X, Y. What is the rule? However, we can take both red and white. The answer should be 3 only. Okay, so X less than or equal to 2, Y less than or equal to 3. So possible of X, 0 white ball, 1 white ball, 2 white ball. Possible of Y, 0 red, 1 red, 2 red, 3 red. Okay. Okay, now I am going to assume 0 white ball, X equal to 0 white ball. If X equal to 0 now, we can get 3 balls only now. So we can take 0 red. So both 0 white, both balls are 0, white balls are 0, red balls are 0. So we can possibly take only 3 black balls. 3 black balls from 4 black balls. Okay, so 0 white ball, 1 red. To compensate 3, remaining 2 balls are taken from black. Okay, 0 white, 2 red. To compensate 1, we can take 1 black ball from 4 black balls. If we take 3 red balls, no need to compensate. So 3 red balls are enough. See, 0 white, 1, 0 red. So total number of balls 9C3. So from 4 black balls we can take 3 black balls. So 4C3, 4 into 3 into 2 divided by 3 into 2. So answer 4. 9C3, 9 into 8 into 7, 3 into 2 into 1. So 3, 3, 2, 4. So 3 into 4, 12. 12 into 7, 84. So 4 by 84. Answer is 1 by 21. 1 by 21. Like that we can find 0 white, 1 red. Remaining 2 black balls are taken. Remaining 2 balls are taken from 4 black balls. So 4C2, 3C1. So we can mention here also 2C0. Like that from 2 white ball, no white balls. From 2 white balls, no white ball. From 2 white balls, no white ball. We can mention that also. Okay, right. What is the answer? 3 by 14. Like that 1 by 7 and 1 by 84. Okay. Next, only 1 white ball. Row X equal to only 1. About 1 white na 0 red na remaining 2 balls we needed. So 2 balls taken from black balls. 1 white, 1 red. So we record balance ball 1, 1 black ball enough. 1 white, 2 red. So already 1 white, 2 red naka 3 balls are over. So no black balls are here. See, no black balls are taken here. 1 white, 3 red na totally 4 balls. Number of balls are required only 3. So this case is impossible event. So to find 2 white ball we are taking 1. 4 black balls we are taking 2 divided by total 9 balls we can take 3. Simplification this 1 by 7. Like that here and here. Finally, exactly 2 white balls. If exactly 2 white balls, 2 white ball, 0 red. So to compensate the number of 3 balls, we need 1 black ball enough. 1 black ball enough. 2 white, 1 red. Totally 3 balls are over. So no black ball here. 2 white, 2 red. Total number of balls 4, not possible. 2 white, 3 red. Total number of balls 5, so not possible. So only this 2 only possible. 2 white ball, 1 black ball. 2 white ball, 1 red ball. So 1 by 21, 1 by 28. Okay, so just write the value 0, 0, 0, 1, 0, 2, 0, 3, and 1, 1, 1, 2, 1, 3. So these are impossible events. Okay, if you want, you may add all these values, answer comes 1. Let us see, check this one. LCM is 84, here 42 only, no. By the LCM 84, numerator 4, here 42 into 2, 84, 18, plus 12, plus 1, plus 12, plus 12, here plus 24, plus 6, here 4, here 3. Add the numerator, we can get 84 divided by 84, value equal to 1. Okay, so probability marginal function of y, py of 0, sum of these rows, columns, py of 1, sum of this column, py of 2, sum of this column. Now px of 0, sum of this row, px of 1, sum of this row, px of 2, sum of this row. Okay, we can get answer. Okay, wow. See the simplification. There we have just swap by x and y place alone. Thank you.